Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others in need of assistance with these topics. So what we're going to be covering in today's video is we're going to be looking at trigonometry, and we're going to be looking at how to use the law of sines and law of cosines in order to find either a missing side or a missing angle of a triangle. And this will be the third part in this series. So we're going to have two triangles here, and we have to find our missing value x for each of those. So with our first one here, well, our missing value of x is a side. And what we also have is another side of 6 and then two internal angles here. So we're either going to use the law of sines or the law of cosines in order to solve. And if you want to, I would rather use the law of sines because it is a much easier calculation. So looking at the law of sines equation, we would have sine of our little angle A over the side A, which is opposite that angle, is equal to the sine of angle B over the side of B, which is opposite that angle. So we already have one side, and we already have the angle that is opposite that side, which is 45 degrees. Well, in order to use the law of sines, we would need to know the angle that is opposite our x here. Well, how can we get that angle? Well, we already know that there's two internal angles right here of 75 and 45. And we also know that a triangle has a total of 180 degrees inside of it. So we can just subtract off 75 and 45 from the 180, and that would give us our angle that is opposite the x, which comes out to be exactly 60 degrees. So this is 60 degrees here. Now we have that angle that is opposite our x, so we can actually fill in the sine equation. So filling it in, let's go with sine of little angle A. We'll just call that 45 degrees. And it doesn't matter which one you call A or B, just as long as you stay consistent with what's opposite that value. So what's opposite my angle 45 is the 6, so that would be my side large A, is equal to the sine of 60 degrees divided by the side that is opposite, which is my unknown x. So we can just cross multiply here, and we would end up, which I'm just going to throw it up here, we will end up with x times the sine of 45 is equal to 6 times the sine of 60. So x would just be 6 times the sine of 60 degrees divided by the sine of 45. And x would pop out to be exactly 3 square roots of 6, or you could write it as an approximation of 7.35. Just keep in mind that you have to have your calculators in degrees mode, not radians mode, when working these calculations. So that's the law of sines, and keep in mind the law of sines, you need less information than you do the law of cosines. All right, so let's move on to our second triangle here. All righty. So with our second triangle here, well, x is also a side. Well, what else do we know in here? Well, we know a side of 5 and a side of square root of 5, and we know that this angle right here is 135 degrees, which is opposite my 5. Well, do I know the angle that's opposite my x so I could use the law of sines? Ugh, I do not. I don't know any other internal angle here. Well, there is a process here where you could use the law of sines twice, and bear with me. So using the law of sines twice, you could use it in conjunction with the 5. So it'd be sine of 135 over 5 is equal to the sine of this angle up here over its opposite, which is the square root of 5. That would give you this angle up here, which we'll just call theta. And then we can use the same process as we used for the previous problem. 180 degrees minus off these two angles gives me this angle, and then I can use the law of sines with x. So that would be using multiple law of sines steps in order to find what your x is. Well, not wanting to use the law of sines multiple times, let's try and see if we can use the law of cosines here. The law of cosines is a little bit more complex equation, but it'd be faster than using the law of sines twice. So the law of cosines equation would be my side c squared is equal to another side a squared plus the last side b squared. Pretty much anything capitalized would be a side. Minus off 2 times my side of a times my side of b, cosine of little c, which little c would be the angle that is opposite whatever I'm calling side c. So with this one, we need to know all our sides, or we would have to know two sides and the angle that's opposite my side C. Well, if I call my 5 my side C, then the angle that's opposite that would be my little c. Well, then I can call this one side A down here for the square root of 5, and then that would give me x here as my side B, and it would be my only unknown in my equation. So let's go ahead and fill this in here. So I would have 5 squared is equal to the square root of 5 squared plus x squared minus off 2 times the square root of 5 times x times the cosine of the angle that's opposite my side of 5, which would be 135 degrees. So let's do some simplification here. And let's also bring over the 5 squared to the opposite side here. So we would end up with 0, bringing 5 squared over. We would have x squared plus the square root of 5 squared is just 5. 5 squared would be 25, and since we brought it over to the opposite side, it'll be negative. And then we are going to subtract off 2 times x times the square root of 5 cosine of 135. Now, keeping in mind this portion right here, cosine of 135 is going to be negative when you plug it in. And you also have a minus sign over here. So it's going to turn this into a positive. And then I'm just going to take this entire expression of 2 times the square root of 5 times the cosine of 135. And I'm just going to turn it into an exact number. So when we do this, we end up with 0 is equal to my x squared doesn't change. This 5 minus off 25 gives me minus 20. And this entire portion right here becomes a positive square root of 10x. And if you wanted to, you could write that out in its actual decimal form if you want to. It's perfectly fine. So I'm just going to rearrange this real quick using higher powers first. So x squared plus square root of 10 times x minus off 20. Well, what do we have here? We have a quadratic equation. So we have to use the quadratic formula in order to solve for x. Some of you may be thinking, well, it'd just be easier to use the law of sine twice. Yeah, it's up to you if you want to. But I'm showing you how you can do it with the law of cosines. So your quadratic equation would be x is equal to b or minus b plus or minus the square root of b squared minus 4ac all over 2a. Where my a would just be what's attached to my x squared, which is just 1. B would be what's attached to my x, which would be the square root of 10. And then c would be my last remainder here, which is minus 20. So if we were to fill in this quadratic formula, we would have our minus b, which would be a minus square root of 10 plus or minus the square root of 10 squared minus off 4 times a, which is 1, times minus 20, which is my c, all over 2 times 1. And this will simplify down to the minus square root of 10 plus or minus the square root of 90 once you solve everything underneath the square root, all divided by 2. And you're going to get 2 roots every time with the quadratic formula. You're going to get 2 different answers. One's going to make sense, one's not going to make sense. And your first one will be the square root of 10, which is 3.16. And your second one would be minus 2 times the square root of 10, which is a minus 6.32. So which one of those does not make sense? Well, we're looking for a side here. Can we have a negative side? No, we can't have a negative side. So this 6.32 doesn't make any sense. So we're left with the 3.16. And that's what my x would be. So my final answer here for x would be the positive one, which is 3.16. And that would be solving that problem using the law of cosines. As I mentioned at the start of problem number 2 or part 2 there, you could use the law of sine twice, and you would also have to find out an internal angle inside there using the 180-degree total. But this was just how you would use it using the law of cosines with one single equation, getting your answer as 3.16. So I hope this video was helpful. And if you want to see more problem solved this Friday, please check out the other videos on our channels. We're trying to upload daily. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does assist us on this end. Thank you for watching, and I hope you have a fantastic day.